Here's another perspective on inverse functions. If I really want to drive home the point that inverse functions involve switching x and y, I can't do it better than with this example with just numbers. Now, as we saw the other day with composition of functions, when you could have a function like g of x, and it could have several ordered pairs that are in the set that makes up g of x, and this is how it would look. Let's say that we want to find the inverse of g. Well, it couldn't be easier. You're going to love this. Out of all the things we learn, this is going to be very straightforward. It's just important that you understand the concept and what's happening here. And it does help us to understand better some of the other things. So I'm going to go ahead and, all we really got to do is this. I said that the main concept of inverse functions is you switch x and y. So look what I'm doing. I'm going to each ordered pair, and I'm simply switching x and y. That's it. It's that easy. Now, just so that you don't think this is a complete waste, and by the way, that is the answer, but just so you don't think this is a complete waste of your time, we'll take a look at an interesting aspect of this. One interesting aspect of this is what happens to the graphs of functions when they're inverses. So let's take a look at what happens if we try to graph a function, and we'll call the function, we'll say it's f of x equals 3x minus 2. And we also want to take a look at the inverse of the graph of that function. Now the cool thing about the inverse of the graph of this function is this, is if I go and I make a table, and here's x, and here's f of x, just like I've done many times in the past, something very cool happens when I want to find the graph of the inverse of this function. First of all, you may recall, we'll put in some sample x values. If this was a quadratic or a polynomial, we'd want to find, more interesting x values. But for a straight line, we can put in these values, and that'll work just fine. So anyways, if I put in a -2, I get negative. I'll go ahead and fill in this table real quick. So if I plug these x values in here, my f of x values will be these. Now let's take a look at what the graph of the inverse of this function looks like. Notice that I don't know exactly what the inverse of this function is, not yet. I haven't done any algebra, but we will in a second. But I know for a fact that if this is what the coordinates look like for this function, then I know that this is what the coordinates must look like for the inverse of that function. Look at that. Didn't have to do any algebra at all. Of course, just for the heck of it, let's do a little bit of algebra. So if we do, what we'll see is this, that if we change this guy to y, so it's y equals 3x minus 2, and then switch x and y, so x equals 3y minus 2, then move the 3y over to the other. Actually, I'm going to go ahead and move the 2 to the other side. So it'll be 3y equals x plus 2. And then divide both sides by 3. And when I do, I get y equals x plus 2 divided by 3. Now, finally, don't forget our last step is we'll change that to inverse of f of x. Again, that's x plus 2 divided by 3. Now, if you don't believe that these guys right here are the inverse of this guy right here, well, go ahead and try it out for yourself. Plug in values of x like -8, -5, -2, 1, and 4 in here, and then calculate. You should see -2, -1, 0, 1, and 2. So this is kind of cool. It's kind of a neat little trick. If I graph this guy, I can easily graph the inverse of that guy. You're going to need to know that. Also, let's take a look at it on an actual graph. So here I have our good old friend Desmos, and this line that you see here, this guy is the line f of x equals 3x minus 2. And you can try it for yourself on Desmos at home. Don't take my word for it. Let me go ahead and make it so that that shows up really clear. So anyways, there's the line. And then I'm going to go ahead and add the line f of x equals x plus 2 divided by 3, which is what we said would be the inverse. So I'll go ahead and show that line. Now there's something really cool that I want to show you here. It turns out that if we graph two functions and they're inverses of one another, they will always reflect perfectly about the line y equals x. Take a look at this line that I just added. This green line, it is the line y equals x. And notice that the red line here is a perfect reflection about this green line with the blue line. So if this green line was a mirror, this blue and this red line are reflections of one another. And the same over here. If this green line was a mirror, this red line and this blue line would be reflections of one another. That's kind of a neat little deal there. So maybe we should add that to our notes. So this would be a worthwhile thing to write down, is that the graphs of functions and their inverses reflect about the line y equals x. Reasonable thing to make note of.